Hi friends, welcome to the Vikram Study Corner. So today topic is the standing waves on stretched string. వచ్చేసి stretched string లో standing waves అనేవి ఎలా ఫామ్ అవుతున్నాయని ఇక్కడ డిస్కస్ చేస్తున్నాం. So first one is we will discuss about the reflection of wave. So first, what is the meaning of reflection of wave? When a pulse or wave is placed on a rigid surface, then it will coming back to the same side is called reflection of wave. That means when you are projecting a wave on a rigid surface, then the wave is not entered into the other side of the surface, then it is coming back to the same surface, then that is known as reflection of wave. So reflection of waves can obey the laws of reflection. So here the reflection of waves can obey the laws of, what are the laws of reflection are existed, it can obey by those two laws. So what are laws of reflection means there are mainly two laws of reflection are there. So first one is the incident ray and reflective ray, both are on the same plane. And next one is the angle of incidence equals to angle of reflection. So these two are the known as laws of reflection. So the reflection of waves should obey these two laws. So the example for this one, reflection of waves example is phenomena of ecosystem. So what is the meaning of echo? Echo means, for example, when you are placing in front of a wall, then we are making some noise, we are listen that sound continuously, that is only known as echo phenomena. So this is the example for this is happened because of reflection of waves. So next, when the wave is placed on a non-rigid surface, then it is entered into the second medium is called reflection of wave. If it is placed on the rigid surface, then it is coming back to the same side. So if you are placing a non-rigid surface, then that wave is entered into the other side of the medium, then it is known as refraction of wave. So here the refraction of waves can obey the Snell's law. So Snell's law is nothing but the angle of sine value of incident to the sine value of refractive angle. The ratio between these two values will be always representing as a constant, that is only known as Snell's law. So sin I by sin r is constant, that is equals to the refractive index of first medium with respect to second medium n12. So this is the reflection of waves. So coming to reflection of waves, the reflected wave has a same shape as incident, but it suffers a phase change of 180 or pi radians. Then so the reflective wave is placed on the rigid surface, then it is coming back to the same medium. So at that time, what is the incident, what is the amplitude it has will be same. There is no change in the magnitude when it is having incident wave. Same value will be available for the reflective wave. Only the change is the phase angle. So for the first one is first wave, for incident wave it is making the phase angle of pi. Then the reflective wave is making the refractive index of pi plus pi. That means 180 degrees changes will be happen to the reflective wave. So because of this boundary is rigid, the displacement must be 0 at all times at boundary. So coming to this one, if you are taking this displacement, so when you are taking the displacement, when the wave is coming from a point, certain point it is started and it is coming back to the another medium, another fixed point, and again coming back to the same position, that's why the displacement will be 0, because of it is where it is starting, then the same that point is coming back to the same at that particular point, that's why the displacement will become always 0 in the case of rigid surface. So by using the Newton's third law, one exerts an equal and opposite force on the string, generating a reflective pulse differ by a phase of pi. So according to Newton's third law, the action is equal to minus reaction. In the same way, based on this one, how much force is applied on the wall by the wave is opposed by the wall in the same way, same force, but the only change is phase difference. It is differ by a phase of pi radians. So if the surface is not rigid, then the wave is moving as incident wave. If the surface is not in, then it is entered into the another wave. This phenomena only known as refraction of wave. That means it is in the case of non-rigid surface. Then the net maximum displacement double the amplitude of each pulse. In this case, when the refraction is happened, at that time the amplitude becomes double because of it is entered into the another medium. That is the example for this one is open pipe. So these are the examples for the reflection of waves. So here if you are taking the wave equation, let the incident wave is y of x comma t equals to a sin of kx minus omega t. Here y of x comma t is representing the displacement and a is nothing but the amplitude of the wave, and sin of kx minus omega t, here kx minus omega t is the argument of sine function. So in this one, k represents the wave number and x is the displacement, where the position of the displacement, how can it is changing, that is the x value, and omega is the angular frequency, and t is the time period in which at what instant the wave is, which position exists, that is the kx minus omega t. So if you are taking a rigid boundary, then the wave will be reflected into the same medium, that's why the reflective wave will be formed. So what is the phase difference between the incident wave and the reflective wave will be pi radians. That's why the equation become y of x comma t equals to a sin of kx minus omega t plus pi. So this is equals to, we know the value of sin of pi plus theta equals to minus sin theta. That's why you are getting minus a sin of kx minus omega t. So this is in the case of rigid surface. So if you are taking a non-rigid boundary, then the reflective wave will become refractive wave. So then this become, there is no phase difference. Then y of x comma t equals to a sin of kx minus omega t plus 0. Then you are getting the equation will be a sin of kx minus omega t. So these are the equations for the reflective wave and refractive wave. So coming to this one, standing waves and normal modes. So what is the meaning of standing wave? So the standing wave means the waves which are traveling between two fixed points are called standing waves. That means when the wave is started from a point A. For example, if you observe in this diagram, there is the first point is node and the ending point is node. So these two are the fixed locations. Between these fixed locations, a wave is transferred into this. So the wave is started from left side and it is entered into the first it is traveling in positive direction, again it is negative direction, and finally it is traveling in the positive direction. Finally it reaches the position. So what is the curved line is existed is known as, it is known as the incident wave, and which is the represented as the dotted lines, it is known as the reflective wave. So these two are separated by, these are different by a pi radians. So that means the wave which is traveling between two fixed points is known as standing waves. So the interface of two identical waves moving in opposite directions produce standing waves. That means the waves which are traveling in opposite directions between the two fixed locations, then they can form combinedly as a standing waves. So let a wave traveling along positive x direction and reflective wave traveling in negative direction, so with the same amplitude and wavelength. So if you observe here, that means the wave which is traveling between two fixed locations, if the incident wave is in the positive x direction, then the reflective wave will be opposite direction. That means it is in the negative x direction, and these both are having the same amplitude as well as same wavelength. So this is the diagrammatic representation for the standing waves. So next, we are taking a value of yi. That means incident wave displacement yi equals to a sin of kx minus omega t. It is representing the incident wave. Then coming to reflective wave, it will be represented as yr, that is yr equals to a sin of kx plus omega t, because of it is in the opposite direction. That is this one. So next we are taking this one. Then the resultant wave using the superposition of waves. By using superposition is nothing but the sum of waves. What are the magnitude of these two waves? We are adding that one. What is the resultant we are getting? That is the resultant wave. Then y equals to yi plus yr. So if you are using that equation, that means a sin of kx minus omega t plus a sin of kx plus omega t. A is common in both terms. Then we are getting sin of kx minus omega t plus sin of kx plus omega t. So if we are applying this formula, sin of a plus b plus sin of a minus b, we are getting 2 sin a cos b. So by using that formula, you are getting 2a sin kx cos omega t. So in this one, what is the value? 2a sin kx represents the amplitude of the wave, resultant wave. So in the above equation, amplitude is 2a sin kx. So the wave pattern does not change with the time. So because of it is not depending on the time, so it is independent of time, but it is the amplitude is changed from point to point. When you are taking a point at starting, the amplitude will be different. At the ending, the amplitude will be different. That means for every point, the amplitude will be changing. That is depends on the point. So the wave pattern is neither moving to the right or left. These waves are called standing waves or stationary waves. That means when you are taking the waves which are not moving either positively or negative direction, so then these waves are coming under standing waves or stationary waves. So for this one, the amplitude is different for different positions, already we said. So based on that one, we can define these positions will be two types. So those are nodes and antinodes. So what is the meaning of node? Means where the amplitude becomes zero. When the amplitude becomes zero, that means where the wave is started, that mean position only the point is existed, it is known as node. Otherwise, when the amplitude becomes largest, that means the maximum where the amplitude is available, the point is known as antinode. So based on these nodes and antinodes, we can define the frequency. That means the fundamental frequency we can find. So the frequency with which the wave is oscillating are called normal modes. That means what is the number of oscillations are happen in a unit time. That is only known as the frequency. So based on these oscillations, we can find these frequencies, and those are known as normal modes. So the lowest possibility natural frequency is called fundamental mode or fundamental first harmonic. That means which is the first one. That means we are having only one wave in the string. At that time, what is the frequency it has? is known as first harmonic or fundamental mode. So if the external frequency is close to one of the natural frequency, then the system is in resonant state. If we are using what is the external frequency, so external frequency is equals to what is the frequency available inside the string, then these two will be equal. Then we said the string is in the resonant state with the surroundings. So these are the standing waves. Then how can you formation? What is the formation of stationary waves in stretched string? So when a stretched string is fixed at both ends and plugged at a midpoint, then the stationary waves are formed. So for example, if you observe the diagram, in this one two fixed locations are there. So in fixed locations we are placing some disturbance is created between the at midpoint. Then the standing waves will, or stationary waves will be formed. So if you observe the diagram, in this one first case, first situation we are having only one wave. So in second diagram we are having two waves, and third one we are having three waves. That means the number of waves will be increasing. So and here in this one the curved line is representing the incident wave, and the dotted wave representing the reflective wave. So this is the diagrammatic representation. So based on this diagrammatic representation, if we take these two, already we said the incident wave and reflective wave all are having the same amplitude as well as same length, and next one is same frequency. So let two transverse progressive waves of same amplitude and wavelength and frequency and traveling in opposite direction. So one wave is assuming as y1 equals to a sin of kx minus omega t. Next one is y2 equals to a sin of kx plus omega t, because of both are traveling in opposite directions. Then the resultant wave is y equals to y1 plus y2. Then y equals to 2a sin, already we find that value by using the sin of a plus b plus sin of a minus b, we are getting 2 sin a cos b. By using that value, the resultant value y equals to 2a sin kx cos omega t. So here 2a sin kx representing the amplitude. So based on this amplitude, if it is minimum value, then we are saying that one node. If it is maximum value, it is known as antinode. Then where the nodes and form, and where the nodes will form, and where the antinodes will form. So to define that one, when the amplitude becomes 0, then we say it is a node. So it depends on the kx value, because of the function, the amplitude will be 2a sin kx. So sin function where will become 0, that means at sin 0 it will be getting 0 value. That means if x value is 0 or lambda by 2 or 2 lambda by 2, the amplitude becomes 0. So these positions are called nodes. So coming to next, if the x value will be lambda by 4 or 3 lambda by 4 or 5 lambda by 4, then we said the amplitude is maximum. Where the amplitude is maximum, then we said the points which are existed is known as antinodes. So this is the formation of nodes and antinodes. So after that one, based on these nodes and antinodes, we can find the wavelength we can find. So if you observe this one, first in this one only one wave is existed. That means between two nodes, the distance existed between two nodes is lambda by 2. Otherwise the distance between node and antinode is lambda by 4. So if you observe in the first figure, there is only one wave is existed. That's why the distance is lambda by 2. That means L value is lambda by 2. So based on that one, we can find lambda value is 2L. So by using that formula, then we are using the velocity of transverse wave in a stretched string will be V equals to square root of T by mu. So here T is representing the tension force of the string, and mu is representing the linear mass density of the string. So if you are using the formula this one, when a stretched wire is vibrating with P loops, that means here if you are observing the diagram, in first one only one wave is there, in the second one two waves are there, in third one 3 loops are available. So based on this number of loops, we can identify the frequency. So if you are stretched string, if you are assuming that one, the number of loops are available P, then vibrating length of the wire will be, then P L equals to P into lambda by 2, because of the length will be lambda by 2 for one loop. So here P loops will be there, then the length will be P into lambda by 2. So based on this one, if you are finding the wavelength lambda equals to 2L by P, we are sending to another side, become numerator, so 2L by P. So next one is we are finding the frequency of the vibration, the frequency equals to N equals to V by lambda. So if you are using V value will be root of T by mu, and next one is lambda value is 2L by P, then you are getting P by 2L into root of T by mu. So this is the frequency of the stretched string. This is here P represents the number of loops in the string, and next one is L is the length of the loop, and T is the tension of the string. And next one is mu is the linear mass density. So this is the frequency of stretched string. So if P value will be 1, in the diagram, first diagram only one loop is existed, that's why P value will be 1. Then that time what is the frequency we are getting is known as fundamental or first harmonic frequency. Already we said, which is the lowest frequency of the wave is known as fundamental frequency or first harmonic frequency. Next one is if p value will be 2, then the frequency is called second harmonic frequency. If the p value will be 3, that is only known as third harmonic frequency. These are the frequencies available in the stretched string. So based on this formula, what is the formula we are getting? The frequency is mainly depends on the three quantities. So the frequency is depends on the length of this one. So what is the relation between these two means? The frequency is inversely proportional to the length of the string. So the length is inversely proportional to that means the length will be increasing, the frequency will be decreasing. If the length will be decreasing, then the frequency will be increasing. That is the relationship existed between frequency and the length of the string. So that is the inverse proportion. Next one is the frequency is directly proportional to the square root of the tension force. That means so nu is directly proportional to root t. Next one is the nu frequency is inversely proportional to the square root of mu. That means the linear mass density. So the relationship existed between frequency and the linear mass density is inverse proportion. Then mu is inverse proportional to 1 by root mu. So this is the value. This is the stretched string question. So if you like this video, please like, share and comment. Don't forget to subscribe my channel. Trivikram Study Corner. Thank you.